Hi there, I'm Luke the Alpha Geek. Today we're going to be talking about microcontrollers and what they are. A PC is a general computer. What does that mean is that it's not designed for a specific purpose. It can be used for a wide variety of things like business application, games, controlling things, and what you can do with them is basically infinite. A normal desktop computer is composed of a motherboard. On the motherboard we have the central processing unit, the CPU. This is basically a chip that is the core of the computer. That's all the processing power of the computer is on that chip. This is an old AMD motherboard, probably from about 10 years ago. The motherboard also has things like random access memory. Here we have a memory chip that is the memory where our software is going to be running. And it's got all kind of peripheral chips like the North Bridge and the South Bridge, which are controlling the inputs and the outputs on the of the computer. Opposing that, a microcontroller is basically a computer on the same chip. I just pulled out of an old project the microcontroller, which is that little chip. You see it's got little pins on the sides, and actually that is the entire computer. In that chip, and this is a PIC, there's a central processing core, there's memory, an input-output controller that can communicate to the real world with those little pins on the side of the chip. So our microcontroller is the equivalent of that big computer that motherboard that we saw, with all of the interfaces to function on the inside the chip. Normally the only thing that we need to implement a microcontroller system is a few capacitors, voltage regulators, and things like a serial communication, so we can program it, or so the microcontroller can talk to the outside world. But most of the system is built in that little chip. This is a PIC, and if you remember the last time I was showing you an Arduino, and the Arduino use an Atmel microcontroller. In the case of the Uno like that, it's Natmega 328, which is in that long chip here, which is the same thing. If we look at the Arduino Pro Mini, the little chip in the center here, let's see, that little chip in the center, that little rectangular little square chip, is exactly the same processor as we have on the standard Arduino, but it's a different package. It's a surface mount package that is very small, but it has all the same feature as the different package of the Arduino. That Atmega 328 chip has built-in. It's a chip that works at 16 megahertz. It's got 32 kilobyte of flash memory, 2 kilobyte of RAM, and 1 kilobyte EEPROM, so you can get the data programmed in that's going to stay put in the system. The 32 kilobytes of flash memory is where normally you're going to be downloading your program when you program a microcomputer. Depending on the type of microcomputers you're going to be using, there's different ways of programming them. Things like the PIC traditionally use a programmer that in the old days was running on a parallel port on a computer, and most of the newer programmers are using USB in the most recent versions. The PIC, normally to program it, you need to pull out the chip from your project using something like one of those very simplistic things or fancier type of things. You just pull the chip out, put it in the program it, and return it to your project. The nice thing about platforms like the Arduino is that the microcontroller can be programmed directly through USB. The Arduino has a USB connector that connects to your computer, and directly from the programming environment, you can actually program the microcontroller on your board. To do so, the Arduino has, in the newer version, instead of just having a serial emulation to USB to serial chip, it actually has, if we can see it, I dip my finger, it actually has another Atmega microcontroller that is used as a USB to serial controller. So you actually have, in this microcontroller board, you have two microcontrollers. One to do actually the work you plan it to do, and one to communicate with your computer. And the nice thing about this is that you don't need a specialized programmer to program your microcontroller. What can we do with microcontrollers? Microcontrollers are used for all kind of things. They can be used, actually nowadays, most of the electronic device you might have around you do have microcontrollers inside them, from a VCR, an old style VCR or a DVD player, or things that control the engine of your car, to your cell phone, to whatever else we can think of these days, have microcontrollers inside them. And what those systems are, we call them embedded system. It's a system that has a microcontroller chip embedded in them to do a specific purpose. Things like a cell phone can do a lot more things, like smartphone can do all kind of fancy stuff with their microcontrollers, but normally you have devices like in your microwave that you can have the timer and the control panel and the LEDs that lights up to give you a display, and all of that are all controlled by a microcontroller. A very simplistic one and a very basic one, but it's still a microcontroller. Things like an Arduino you can program to do all kind of things. The microcontroller, as if we look at those sockets here on the side, depending of which pin is connected, you can have inputs and outputs. What does that mean? Input is when data comes in, like a sensor is read by the microcontroller, and you can calculate things or log the data or send them somewhere else with either by cable or wirelessly. And in this way, the microcontroller can read data and act on it. So you can do something like a basic thermostat where you have temperature sensors, and when the temperature goes down, you can start a heater, or when it goes up, start something to cool the temperature, or start a fan, some basic things like that. Also, the microcontroller has output pins. And what can you do with the output pins? You can drive displays, you can, to show data, you can control relays to start devices that needs more voltage that the microcontroller can control on its own. And with all of these things, the microcontroller can perform all kind of functions that can be from very basic to very complex. You can have art display when people will do something, the microcontroller will control things. It can control and send signals for music systems. The possibilities are endless. I'm going to try to do something a little bit more fun than just flash an LED, but we're going to start doing some basic things and start to have fun with basic electronics and microcontrollers. And at the same time, probably we'll do different topics depending of what interests me, depending on the day. So have fun until the next video, which should be up probably in a few days.